Hello everybody, once again I am Dr. Abdel Monem Hamid, the Professor of Ophthalmology, Banha University and the former Fellow of Baylor College of Medicine, USA. My topic today is about the artificial intelligence in keratoconus dilemmas. We are talking nowadays about the artificial intelligence because we have a lot of data, so it is easier if the machine can resolve it like a calculator. The artificial intelligence is expected to give the ophthalmologist new automated tools for diagnosis and treating the ocular diseases. So the question now is, what are the artificial intelligence algorithms? The first one is the simple automated detectors. It is the simplest form of artificial intelligence. The programmers give the software mathematical descriptors of the feature to detect it. Basic machine learning. They send to the machine a training set of images from the affected and unaffected eyes. So the algorithms examine the images to learn about the differences. Is the advanced machine learning. It consists of one or two interconnected layers of small computing units called neurons. The final one is the deep learning with convolutional neural network, CNN. It is called the black boxes. The term deep learning means training the multiple interconnected layers, which comes closer to thinking. So, how can we get benefit from the artificial intelligence in our daily life? We can get this benefit by sending the data of the topography to the computer or the machine. Then we ask the machine to apply the algorithms. Then we can print out the result. As you can see in this video, this is a module number 1 for the practical subjective score system 3. So in this module, we can enter all the data of the topography of the right and the left eye. After entering the data like Kmax, sinus local, the difference in sinus local between the two eyes, etc. So we can here get the values of the normal value of the population, also the value we entered for that eye, and here we have the inter-eye asymmetry, and finally we get the doctor guide according to the practical subjective score system, and I'm going to illustrate all of that in the next slides. This is the first print out of the calculator. What we are seeing now in the red box is the data that we enter its value inside the calculator, like the k-mean, difference in the mean anterior k between the two eyes, and the difference between the mean posterior k between the two eyes, like the Kmax, like the K2, like the difference between Kmax and the K2, the sinus local, the Q value, etc. All these data of the topography for the right and left eye for that particular patient. And on the second column, we have the normal values that we have. If we exceeded the normal value, so we will be differentiated. Either we have a moderate risk value or a high risk value. And after that, we have the values of that particular patient that we entered inside the calculator. And according to the data we entered, we have, for example, over here the right eye, it has most of its value in green color, which means it's a normal value. And with respect to the left eye, we have most of its value in orange color, which means it has a moderate risk value, and also the left eye has two high risk values in the red column. So all of these data we can print it out and attach this paper to the patient file. We have also a print number 2 of this calculator, which give us the inter-eye asymmetry. So in this printout, we can check the difference in mean anterior K, mean posterior K, and the zenith local between the two eyes, and elevation at the zenith local, front elevation and the back elevation at the zenith local between the two eyes. And as you can see here, right eye of this patient, it has moderate risk values in the row number 1 and number 2, and the left eye, it has 5 moderate risk values. Both eyes don't have any high risk value. So according to this, the right eye has 2 points and the left eye has 5 points. So we'll give the right eye a score 2 and the left eye a score 4. And this is the final print number 3 of the practical subjective score system, which guides the surgeon what to do for this patient, what to do for this particular patient. So according to the PS3, the particular subjective score system 3, and the data we enter for that patient, so we can, as you can see here, we have no risk value for the right eye, so we can do either PRK, smile, or LASIK for the right eye, and with respect to the left eye, we have more than 2 moderate risk value, and we have 1 high risk value over here, and score 5 also. So it is not recommended to do anything for that eye. We cannot do either PRK for that eye. This is the module number 2. We can apply a calculator for this EPIC scoring system also to facilitate for us the calculation. Instead, we calculate it manually. Also, we can make a module for the ICRS nomogram, like the 5th generation Ferrara nomogram. As you can see here, we have, according to the backfloat, either lagoon or isthmus, this shape, or peninsula. So according to the nomogram, if we have nipple or lagoon, so we can insert arc length 210 or 320 according to the amount of the astigmatism. Also, if we have isthmus or pellucid margin degeneration, we can insert arc length 140. If we have a peninsula or oval shape in the backfloat, we can insert 160 arc. And the choice of the thickness, it will be according to the desired Q value, and we have to target this minus 0.23 value. We have to target to reach this value for if we can do that. And according to the topographic astigmatism, if the astigmatism is below 3, we can choose arc length 210, and if it is above 3 diopter, we can choose arc length 320. This, of course, for the nipple-shaped backfloat of the. This video will show to us how can we choose the ICRS for the Ferrara 5th generation nomogram. This calculator is found on this website of ejlsa.com site. You can go through this site and you can yourself write the patient ID over here, choose right or left R, and choose either Ferrara 5, Ferrara 6, or intact SK, and you check these boxes and press next. I will show you. You can choose one of those. I chose the Ferrara 5, for example. I will press next, and over here I will see the shape of the backfloat of the back elevation. I will choose, for example, here the nipple cone, and I will enter the K1 and K2 and the axis according to the topography of that patient. Also, I will put the pachymetry over the C-best axis and over the thinnest patch where the ring will be inserted. After that, I will print the form. And as you can see here, it gives me everything: the incision size, the incision length, the depth, incision depth, the segment. For example, here the segment arc 220 and the thickness should be 150, and it gives me the shape of the ring where it can be inserted in the cornea, and this is the incision size and this is the incision depth, of course, with the film tool place. After that, you can print this paper, which has all the data of that patient, and you can work on it during the operation, and also you can attach it to the patient file. We can apply the artificial intelligence also for detection of the progression of the keratoconus, which is defined as loss of 2 lines of best corrected visual acuity or increase in Kmax by 1 diopter during 1 year follow-up. Or a change in the key mean more than 1.5 diopter, or decrease in the thinnest local more than 5% is seen in 3 consecutive topographies in 6 months follow-up, or a change in the myopia or the astigmatism more than 3 diopter within 6 months. If we found that it changes, so we can proceed to do cross-linking for the patient. So all of this data can be included in a calculator to calculate for us instead of us, so we can prevent the human error during the calculation. To take home message, so we do need to understand how the nomograms work. However, it is not necessarily to memorize them, since the intelligent machines can memorize them and compute their results. Thank you very much.